I want you to imagine that you are going to a vending machine and you see the snack that you want and it is A1. And so you press A1 and then down comes the honey bun that you wanted. And then a friend comes up and they say, hey, could you also get me a honey bun? And you're like, for sure, I got you. And then you put in the money, you press A1 again, but this time instead of getting a honey bun, you get some Cheez-Its. And you're like, that's weird. I like Cheez-Its, I'm gonna keep them, but I still wanna get my friend this honey bun. So you put some more money in and you press A1 again, and this time you get some fruit snacks. Well, surely this machine must be broken, right? Because you press the same button, but you got a different snack every time. Well, in this lesson today, we're talking about, is a relation a function? And the answer to that question is similar to our example here. I want you to think that a function works like a good vending machine. When you press one button for the input, you expect to get one snack for the output, okay? You don't expect to get different outcomes. And so that analogy is going to help you understand, is a relation a function? Let's dive into the lesson. Hey, what's up, chat? Welcome to Unit 7, Day 1, is a relation a function, all right? And so in this lesson, we're gonna be looking at ordered pairs, tables, and graphs, and determining whether or not a relation is a function, all right? So let's start by talking about what a function is, okay? A function is when you have an x value that is paired with only one y value, okay? So in the analogy that I gave, or the example about the vending machine, anytime you press a button, you expect to get one snack. You don't expect to get different snacks. So for every button, there is a snack, okay? But if you press the same button and you end up getting different snacks, then that's a broken vending machine, and that is not a function, okay? And so a relation is a set of ordered pairs, okay? And oftentimes we think about these are X and Y, okay? Or we also can refer to them as being some input and getting some output, okay? So the X is what you put in, the Y is what you get out, all right? And so that is how we can think about a function. And the three ways that we're going to see functions represented in this unit, there are more, but these are the three we're going to focus on. The first is an ordered pair. The second is a table, and the third is a graph. And so you can use these interchangeably, but we're going to be working with these three all throughout this unit, okay? And so I have my ordered pairs, okay? And so my ordered pair, the first number in my ordered pair represents the X value. The second one represents the Y value, okay? All right, and so that is the case for my ordered pairs. All right, so I'm going to take this set of ordered pairs and I'm going to create a table. Okay, so for every, when I input 5, I get out 2. When I input -7, I get out 1. When I input 0, I get out 3. When I input 4, I get back -4. Okay, so that is just taking this ordered pair, putting it into a table. Now to graph it, right? Well, to graph on the coordinate plane, I start at the origin. I'm going to graph 5, 2, so I'm going to go over on the X first, right? So 1, 2, 3, 4, 5. Then I'm going to go up 2, all right? And that's point 1, okay? Then -7, 1. I'm going to start at the origin. Then I'm going to go back -7 along the x-axis. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 1. All right, that's my second point. Then I'm going to go 0, 3. So I'm going to start at the origin. I'm not going to move there. Then I'm just going to go up 1, 2, 3. Okay, and then lastly, I'm going to go 4, -4. Start at the origin. 1, 2, 3, 4. Then I'm going to go down along the y-axis. 1, 2, 3, 4. And that is my point. Okay, and so that's just a review on how to, right? We can have them, sometimes we're going to have them listed as ordered pairs, sometimes as a table, sometimes as a graph, okay? And so this is kind of the big idea that you have to remember for today. For the relation to be a function, there must be one x coordinate for each y coordinate. In other words, this is another way of describing that same statement. The x value cannot repeat. Okay? So, again, just to think back to our opening illustration, right? When I press a button to get a snack, when I press the button, I should only get one snack. I shouldn't press the same button and get a different snack, okay? In other words, once there's for every one button, there's one snack. Well, for every one x, there's one y, okay? For every one x, there's one y. The x's cannot be repeated. I can't put in one x value and get two different y values, all right? So I'm going to do the first two, and I'm going to let you try to do the second two on your own. So the first one, right, I'm deciding if this is a function. Well, to decide, I have to look at the x values, okay? And remember, the first in the ordered pair is the x's. I'm looking at these x values, and I'm asking myself, do these repeat, okay? So, again, I've underlined it. If you, as you're taking notes, maybe you want to highlight, right? These are my x values. This is what I'm looking at, all right? Do any of them repeat? If they repeat, the machine is broken, right? Giving you a different snack is not a function, okay? So, in this case, this would not be a function, right? Because there is two threes. I got a 3 here, and I got a 4. Then I also put in a 3, and I get a -9. Those are two different, so it is not a function, all right? Now let's look at the second one. Got 3, 4, 6, 5, okay? Well, I want you to notice in this one, okay, the y's, there is a repeat there, okay? The 4, there's a 4 here, and there's a 4 there. But I need you to understand, to determine whether or not it's a function, you're really only paying attention to the x values, okay? The y's can repeat, but the x's cannot. So we have 3, 4, 6, and 5. So is that relation a function? The answer would be yes, because the x values do not repeat, okay? Now, with that in mind, I want you to pause the video and see if you can do the next two on your own. All right, so for this one, number 3, we got 0, 4, 0, and then 8, right? So we know that this is not a function. And why is it not a function? Because there's 2 zeros, because the zeros repeat. Okay, so this is not a function because there are 2 zeros, all right? And then lastly, I'm looking at 8, 34, 6, and 6. Okay, again, same thing. This is not a function. Why? Because the 6's repeat. Okay, so there's 2 6's and they repeat, therefore it is not a function. All right, so that first set, we determined if it was a function using ordered pairs, okay? Now we're going to see if it's a function using tables. Unfortunately, my tables here are cut off, so let me fix that really quickly. All right, so here are my tables, okay? And in these tables, again, I want to start by looking at the x values and seeing if the x values repeat. So I got a 5, got a 3, I got a 4, I got a 7, I got an 8. I'm looking, are there any repeats? None of these repeat, so this is a function. We're going to say yes, it is a function. Okay, let's look at the next. Look, matter of fact, you go ahead and do the next two. Okay, again, same thing. You're looking at the x values, do the x values, repeat. Simple enough. All right, we got -4, -3, -2, -1, and then the -3. And we're going to say this is not a function. Not a function. All right, because the x's repeat. Because there's two -3s there. All right, and then lastly, 1, 2, 3, 4, 5. This is, yes, it is a function. All right. So, guys, I hope you're thinking that this is pretty straightforward, right? Again, to determine whether or not a relation is a function, you're looking at the x values, okay? Now, lastly, we are going to look at graphs, okay? And graphs is still pretty simple, okay? But there is a little bit more to do here, potentially, okay? All right, so I'm going to teach you two different ways to determine whether or not a relation is a function when you have a graph, okay? First one's going to require a little bit more work. Second one's easy, but I want to make sure that you know how to do both of them, all right? So first thing I'm going to do is I have this graph, and I have all of these points, okay? So the first thing I want to do is I need to figure out what are the ordered pairs for each of the points. So I want you to pause the video, and for this first one, I want you to go ahead and see if you can identify what are the ordered pairs for each of the points. And if I were you, I would just start from the top and then go down, okay? That way you put the points in order. So start here, then move to this point, this one, that one, and then, okay? So go ahead and do that now. All right, so the first point, the coordinates here is -3, 4. Then we have, I'm going to this point, I got 1, 2. Then I got -2, 1. Then I'm here with it, 4, -2. And then 0, -3. Okay. So those are the coordinates for each of my points, my graph points, all right? And then I'm going to look at my x's. Do any of the x's repeat? I got -3, 1, -2, 4, 0. And we're going to say, yes, this is a function. Why? Because the x's do not repeat, all right? That's it. Hey, I want you to go ahead and do this next one on your own. All right, so we got 2, I'm sorry, not 2. We got 1, 2. Then we got 3, 1. Then we got 1, -1. Then we got -3, -2. Then we got -1, -3. Then we got 1, 2, 3, 4, -3. Okay, and so this one is not a function because I have two 1s. Okay, so this is not a function. Okay, not a function because there are two 1s that are for the x values. Okay. All right, so here is the way we're going to end. The way we're going to end is I'm going to show you what is called this is another way to check a graph and determine whether or not a relation is a function. And this is called the vertical line test. All right, so if you can draw a straight line, actually a vertical line, it has to be up and down. Okay, so a vertical line anywhere on the graph, and it hits more than one spot, then it is not a function. I'm sorry, hits the graph in more than one spot, then the graph is not a function. Yeah, okay. So it can only, if I draw this straight line, okay, it can only hit my graph on one line, okay? So I'm just gonna show you my lines by drawing dotted lines. And again, it can be anywhere on the graph. So if I do a dotted line here, or if I do a dotted line here, it only crosses my graph at one spot, so it is a function. Okay. Okay, now in this case, if I draw this straight line, you see this hits my graph at two spots. So this is not a function. Just say no. Okay, no. All right, same thing here. What I will tell you is all of these graphs right here, these are more complex than what you're gonna see in this unit. I'm just showing you this vertical line test, but when you get to high school, those are the type graphs that you're gonna be working with, right? Again, same thing in this case. If I draw a line here, it now touches two spots, so it is not a function. No, all right? If I draw a straight line here, okay, it still only hits 1 point, so that is a function, okay? Same thing here. If I draw a straight line, vertical line, it only hits it at one spot, so it is a function, all right? And again, let's go back up to these, all right? If I drew straight lines on this one, it would be a function. But if you will notice, if I use the vertical line test for this one, if I draw a straight line there, it hits my points two spots. That's why it is not a function, because it fails the vertical line test, all right? And so, hey, in this lesson, we have learned how to determine whether or not a relation is a function by looking at the x values and seeing if it repeats or not, or using the vertical line test for a graph. I hope this helps. Peace.